Welcome. Yep, welcome. Today's topic is number system. Now, on the basis of previous year gate papers, I divided number system into four parts. First one is conversion. Second one is arithmetic operation. Third one is complements, and fourth is sign number representation. On the basis of previous year gate papers, I divided these four parts. Okay, this number system into four parts. First one is conversion. You know very well how we can convert decimal to octal, octal to decimal, then binary to decimal, decimal to other system. These are come into conversions. Okay, now we know binary number can be represented into two digits. First one is 0 and second one is 1. Then we have what? We have 8. 8 means we have octal number. Octal number can be represented into 7 digits from 0 1 up to 10. We have 10 base means we have decimal number. Decimal number can be represented into 9 digits from 0 1 up to 9. Okay, then we have 16 base means we have hexadecimal number can be represented into how many digits? Into 15 digits from 0 to 15. Okay, this is what base and a digit. Here I wrote a number system with a base r will have r different digit from 0 to r minus 1. This is, we have base r means 2, we have 8, 10, 16, and we can represent will have r different digit from 0 to r minus 1. From 0 to 1 means base to r minus 1. Okay, now the basic model of conversion is what? Any system, any x base system can be converted first to what? First to decimal, then decimal to any other system of a base y. Okay, this is the basic conversion. This is basic model of conversion. Means we have to convert x from x base to y base. First of all, we have to convert it into base 10, then base 10 to any model. This is basic model conversion, but we are not following that. We have many shortcuts to solve conversion. Here I divided conversion into 5 parts. First is any system to decimal. This is what I said, that here any system first converted into decimal, then decimal to another system. This is the basic criteria for conversion. Okay, now any system can be converted into decimal. This is my first part. This is second part, decimal to any system. Then this is third is what? Binary to octal or hexadecimal we convert. Okay, then fourth one is octal hexa to binary, then fifth one is octal to hexadecimal. This is the basic criteria for conversion. Okay, now we are going to discuss all this conversion one by one. First one is any system to decimal number. Okay, second one is what? Decimal to any system. We are going to discuss this one by one. Okay, here the first conversion is what? Any system to decimal means just remember that we have to multiply. Okay, just remember that we have to multiply means we have they give any question means like that. They gave 1011.101. This is binary number. We have to convert it into what? Into decimal number. Okay, decimal number. Here we have two parts. First part is decimal part, and second one is fraction part. Okay, fraction part. Here I wrote here what? Decimal part. We have to multiply this decimal part by base in increasing power. Okay, here we have fraction part. I wrote here what? Fraction part. We have to multiply fraction part with base on decreasing power of base. Okay, now how it is I will tell you. Means we have to convert this into this. Means here what is base number? R value is 2. Okay, R value is 2. We have to write this. First of all, take decimal part. Decimal part is what? 1001. Okay, 1001. We have to take 1 means we have to multiply it 2 to the power 0. Okay, I wrote here x1 r to the power 0, here x2 r to the power 1, x3 r to the power 3, and after decimal we have to multiply this digit with decreasing power of base. Okay, here I give 2 to the power 0 plus, here what we have? 1 2 to the power 1 plus 0 2 to the power 2. Okay, here 1 plus 1 into 2 to the power 3. Okay, then plus After this fraction part, how we can calculate this fraction part? 1 into 2 to the power minus decreasing order of base, okay, plus 0 into 2 to the power minus 2 plus 1 into 2 to the power minus 3. This is how we calculate. Okay, this is what, this is base 10. Okay, now here what is the value here? 8 plus 0, okay, plus 2 plus 1, okay, 1 by 2 plus 0 plus 1 by 8. Okay, this is base 10. Okay, now this is decimal part, this is fraction part. Okay, now what I wrote is this is 11 plus what, 0.5 plus 0.125. okay, 1 by 8, 1 by 2. okay, value. Now how can I write 10.6625, okay, plus add these two number, we get this. Okay, this is what, base 10. This is how we can calculate any number to the base 10. We have to just multiply with the base on increasing power of base, decimal part to increasing power of base, and fraction part to decreasing power of base. We have to multiply. Just remember that any system to decimal we have to multiply. Okay, we have to multiply. This is how any system to decimal conversion. Now we have second part. Decimal to any system decimal to any system conversion means we have to divide. Here we multiply, here we have to divide. Okay, here we have to divide means, first of all, what method is what? This is question 19.125 10. What is binary number of this decimal? Okay, this method is what? First of all, consider decimal part, then consider fractional part. First consider decimal part. We have to continuous divide by base r. Okay, and for fractional part we have to multiply with base up to what? Up to, we have to stop where we get a decimal number. Okay, this is I have to take 19. Okay, I consider this part, means fraction part. What I told you that continuous division by base r. Okay, what is the base value is here? 2. R value is 2, means we have to divide this. How can I divide this? Means I have to divide 1 by 1, means 9 to the 18. Okay, 9 to the 18, and here I got 1 remainder. Okay, then after 4 to the 8. Okay, I have to multiply this. 4 to the 8 means here I have to divide by 2, means 9. After divide by 2 I got 4, and the remainder is and remainder is 1. Okay, here also remainder is 1. Remainder here, after dividing this 2, remainder is 0. After dividing with after dividing 2 by 2, we got 1. We got 1 by 1. Okay, we have to write like this, means 19. How can I write 19? This decimal to binary, how can I write? 1 0 1 1. This is 1 0 1 1. Okay, this is I wrote. After this I have to consider what? I have to consider fraction part. Okay, what is fraction part? Fraction part is 0.125. okay, this is 0.125. I have to multiply. I told you that always multiply with a base, that we have to multiply this 2, then we get 0.25. Here decimal part is what? Decimal part is what? Decimal part is 0. Okay, here decimal part is 0. Okay, after 0.25 multiply by 2, I got what? I get 0.5. The decimal part is what? 0. Here 0.5 into 2, I got 1. Here decimal part is 1. I have to write like that. Okay, means 0.125 to the base 10. I gave this, I wrote here. Okay, 0.25 I can wrote what? 001 to the base 2. Okay, this total, how can I write total? I can write for 19.125 the base 10. I can write this 19 means 1011, and for this point is, for 1 to point to the base 10, what I have to write is 001. Okay, this is conversion. This is decimal to any system conversion. Here I took base 2. If you can take any base, means I can also convert it into octal, means I had to divide with what? I have to divide with 8 here, and I had to, if fraction part is given, then I have to multiply with base 8. Okay, up to where? Up to 1, means up to the decimal number. Here we got decimal number 1. Okay, that's why I wrote 1 here.